Good evening, respected chair. I have chose diabetes dataset as my test dataset for the Ascension Hackathon. As given in the challenge requirements, we have to analyze the dataset using RapidMiner. So, according to the instructions given, I have downloaded the RapidMiner and I have included the dataset from Table, this diabetes dataset cited to Akshay Dattatray. The dataset size is 9 KB and I've chosen this dataset because it is small and it is difficult to achieve a higher accuracy for a small dataset. So after I uploaded it into RapidMiner, I clicked on Auto Model and I have set my output parameter as the outcome of the dataset. The CSV file of the dataset is 1 second. I'll show. Yeah. Uh, yeah. This is the CSV format of the dataset, where it has 9 columns. The dataset completely contains of 9 columns, and the columns are namely pregnancies, glucose, blood pressure, skin thickness, insulin, BMI, and age, along with diabetes pedigree function. Then we have the output column, which is binary. It's of ones and zeros, indicating whether the person is diagnosed with diabetes or not. So, regarding the structure of the data set, we have firstly pregnancies, indicating the number of times the patient has been pregnant. It ranges from 0 to 17, indicating that the person has either never been pregnant or has been impregnated multiple times, the patient. And then we have glucose, the indicating the plasma glucose concentration after a 2 hour oral glucose tolerance test. And then the blood pressure. Uh, we are not taking the systolic blood pressure. We are only measuring the diastolic blood pressure. And then we also take into consideration the skin thickness, like the triceps skin fold test done by the doctors, and insulin level in the blood. Uh, we also take into consideration BMI and diabetes pedigree function as per the respective healthy human levels. Going to the data exploration insights, uh, the statistics are, as I told, the pregnancies range from 0 to 17, indicating patients have been never been pregnant or they have been impregnated multiple times. And the glucose in this data set varies widely, indicating different levels of glucose and intolerance or diabetes severity. Uh, and then blood pressure. The blood pressure also varies significantly, which is typical in a diverse patient population. And then the age varies from 21 to 69 years, indicating a broad demographic. Some key observations in this data set are the missing values, the zero values in the column, skin thickness, insulin, and blood pressure, and BMI need careful handling. And we use imputing to handle those things. We imputed them with mean and median or using more sophisticated methods, which I'll be discussing in the code explanation part. And also we use the SMORT technique, synthetic minority over oversampling technique, uh, which is used to balance the outcome variable, just to avoid issues with class distribution. So coming to the rapid miner, once I've imported the dataset, the 9 KB dataset, I've ran it through all models. I clicked on auto model and it gave naive Bayes as with the highest accuracy, 75.9. It says that it is the best gain percentage. It has the best gain percentage. Although this is my first time using Rapid Miner, I learned a lot that uh, it is easier to it is easier to come to a conclusion whether which model performs the best among multiple models. Like here, RapidMiner used like 205 models to evaluate my data set and to tell which model suits my data set the best. And we can clearly see Naive Bayes has the best gain, and next the generalized linear model, and then logistic regression, and so on. That's for the accuracy, and there are not much changes in the others also. Classification error also. There are not much changes because uh, the leaderboard stays the same for all models and all evaluation metrics. Coming to the code explanation part, uh, as we know now, of course, we do the basic imports, the pandas and the sklearn libraries. We imported naive Bayes theorem because, we use naive Bayes theorem, the naive Bayes classifier, because as shown here by the rapid miner, I'm sorry, rapid miner, it has the highest accuracy and highest classification error. I mean, the least classification error. So we are going ahead with it as the base model, and we'll be also using the gradient boosting classifier and random forest classifier along with the voting classifier to improve the accuracy. So here, while coming to explaining the part, we load our data set as usual, and then we declare our features, which are the columns of our CSV file. We just declare them, and then we declare the target also as the outcome, which is the last column of our CSV file. And then just a second. And then we are after defining the features and the target, we are splitting the data set. We are splitting the data set X is equals to data of features, where we are telling that we will be giving features as input and we want the data of target as output. So we are going to train it. So we are doing XY data train split. We are splitting the data set, separating the data set features from the data frame and separating the target from the data frame. And we are splitting the training and testing sets with 80% for training and 20% for testing, as shown here. Test size is equals to zero point 0.2. After that, we will be defining our naive Bayes model here with a variable NB model. We initialize the naive Bayes model here, and after that we will be training the model using we'll be fitting the training data set using X train, Y train, and B dot model dot fit. We'll be training the base model, and after training the base model, we'll be making predictions and we'll be correcting itself here accuracy score. After evaluating itself, it'll improve its accuracy. The same thing we do with gradient boosting classifier and random forest classifier. And we again make predictions on the test data for the gradient boosting model and random forest model. We evaluate their respective accuracies and we print them. After that, we ensemble the model. Now, this is the most important part of my model, where firstly, some notable points of my model are firstly, I use the most accurate and the most suitable model, which is the naive Bayes model as my base model. And then we incorporated it with, I mean, integrated it with the gradient boosting and random forest models to check its accuracy, to improve its accuracy. And then we are ensembling it with a voting classifier model here. We are ensembling it with voting classifier model. We train the ensembling model using the training data and then make predictions on the test data using the ensemble model. Then, as usual, we evaluate the model to get its accuracy after assembling. And then we declare two instances. The first instance is stating that according to the data set, there are three pregnancies. One second. Here, the first column is pregnancies. So we check we declare that there are three pregnancies and respectively like that. Glucose level, blood pressure, and all. I took this data from like openly available data from Google, one of a non-diabetic patient and another of a diabetic patient. This is of a diabetic patient and this is of a non-diabetic patient. So I will run it and then see here as it shows for the non-diabetic patient, we have the predicted outcome 0, which is correct. And for the diabetic patient, like with six pregnancies and 148 glucose level, age 50 and all, we have the predicted outcome as 1, which is true for a diabetic patient. So this is my model with an accuracy of 77%, similar to the one given by our rapid miner model, which is 75.9, and mine was at 77. And then the gradient boosting accuracy is 75, random forest accuracy is 72, and symbol model is 74. I could have used this. One second. Hmm. I could have used this smart technique to improve my accuracy, but the issue is the dataset's size is low. It is small. It is just 90 KB, sorry, 9 KB, and it is difficult to improve on such a small dataset for a model like this. That's it. Thank you.